All right, we are about to jump into one of the biggest, deepest mysteries in all of science: consciousness itself. I mean, what even is it? Where does it come from? And for the very first time, how can we make the leading theories about it, well, how can we make them fight to the death in a proper scientific arena?
Okay, let's just dive right into the heart of the problem, shall we? We all know what it's like to be conscious. It's the most obvious thing in the world, right? Feeling happy, seeing the color blue, hearing a song. But how on earth do you take that purely internal, subjective feeling and nail it down with objective external science? How do you find the source code for a feeling inside the brain? So, to try and solve this, scientists have come up with some really powerful theories. And today, we're not just going to look at them. Oh, no. We are putting 3 of the heavyweights into the ring to see how they actually stack up against each other when the pressure's on. First up in the ring, we've got DAIM. You can just think of this one as the boundary hunter. The big idea here is that consciousness happens when a system creates a stable, informationally sealed-off bubble, kind of like the membrane around a living cell. It creates a hard line between what's me and what's not me. For the boundary hunter, that sovereign, self-contained unit is the conscious self. Next up is IIT, or as we'll call it, the complexity calculator. Now, this theory makes a really bold claim. It says consciousness isn't something a system has, it's something a system is. It's basically a direct measurement of how complex and interconnected the wiring of a system is. The more integrated the information, the more conscious it is. Simple as that. And our third contender is PhEP, the prediction engine. This theory looks at the brain as, well, a machine whose main job is to constantly predict what's going to happen next. And consciousness, in this view, is a huge part of that process. It's the brain's best, high-level guess about the world, and it's all in the service of one thing: minimizing surprise to keep us alive. So there you have it. We've got the boundary hunter, the complexity calculator, and the prediction engine. 3 really different ways of looking at the same problem. So how in the world do you figure out which one is right? Well, you don't just compare them on a whiteboard. You force a confrontation. You make them fight. And this, right here, this is the genius of this new approach. It's a huge step forward for a field that's been kind of stuck in philosophical arguments for centuries. See, the goal isn't just to find evidence that supports your favorite theory. The goal is to design experiments where these 3 contenders predict totally different things. You create a scientific clash where there can only be one winner. And that brings us to the main event: these discriminating tests. This is where we get to see exactly where these powerful ideas split apart. This is where the rubber really meets the road. Okay, for our first test, imagine 2 little agents. They're both doing the exact same task. Agent A is the real deal. It's got its own brain, making its own decisions. But Agent B is a puppet. It looks identical on the outside, but really it's being controlled by someone else, like a marionette on strings. Now, this is where it gets interesting. For that puppet, the boundary hunter says, nope, you won't find a strong, sovereign self in there because the real control is outside. But the complexity calculator would say, hang on a second, if the puppet's internal circuits are still really complex, it could still be highly conscious. And the prediction engine would point out that the real predictive model isn't even inside the puppet at all. It's a total conflict. So here's the knockout question. If scientists run this test and they measure super high complexity, but they find no stable internal self-boundary, well, that's a direct contradiction. It would be a case where one theory's consciousness meter is cranked to 11, while the other's is at 0. That's how you tell them apart. Let's move on to our second test. This one is based on something you can actually experience yourself. It's called binocular rivalry. It's what happens when you're shown a different image in each eye. Your brain doesn't really blend them. Instead, it flips back and forth, first seeing one, then the other. Your conscious experience literally breaks into fragments. And wow, does this show how differently they see the world. The boundary hunter predicts you'd actually see multiple information boundaries, like little competing selves fighting for control in the brain. The prediction engine sees it more simply. The brain is just flipping between its 2 best guesses about what's out there. And the complexity calculator, it might just say the overall consciousness level is still high without having a neat way to explain the flip-flopping content. So once again, a clear, testable prediction. If we can use brain scans to actually see these separate information boundaries, these peaks, and watch them switch back and forth in perfect time with what the person says they're seeing, that would be a huge, unique piece of evidence for the boundary hunter's view of the world. You know, a good scientific theory isn't just about being right.
It has to be falsifiable. There has to be some observation that could prove it wrong. So, what would be a knockout blow for our contenders? What would it actually take for them to fail?
For the boundary hunter, it's pretty straightforward. If you put someone under anesthesia and they lose consciousness, but that information boundary, that so-called self, doesn't change at all, that's a massive problem. Or even worse, what if you find a super strong sovereign self-boundary in a comatose patient? That would be a critical failure. For the complexity calculator, the biggest danger is what's called a false positive. If its math consistently finds an incredibly high consciousness score in a system that we're pretty sure is unconscious, like, say, a very complex computer network, then the theory is in some very serious trouble.
And for the prediction engine, the danger is a little different. Because it's so flexible, its biggest risk is that it could explain anything you throw at it after the fact. And if a theory can create a just-so story for any result, it's not really predicting anything. It loses all of its scientific power.
So what's next in this whole showdown? This isn't just a thought experiment on a blackboard. The actual battle plan for the next wave of research is already being written. And here it is. The roadmap is clear. First, you actually build that puppet agent test and you measure the telltale signs from all three theories. Second, you use advanced brain imaging to map what's happening during that fragmentation task in real time. And third, and this is wild, you directly stimulate the parts of the brain that the boundary hunter points to as the self-hub and see if it messes with a person's actual sense of self. So, do we have a winner yet? No, not even close. But for the first time in history, the contest is real. We're finally moving beyond just philosophy and into hard, experimental science. And while the grand prize is understanding the very nature of our own minds, the most important thing is this: we finally have a way to referee the fight. The showdown has officially begun.